Video 2. Let's apply those tips to the 2020 question. So there's part A, and there are my tips in the bottom left-hand corner. The first thing I'm doing is looking for a differential equation. I can see dx dt is equal to k into p minus x. From that immediately, I can go to tip 2b, identify the variables and the constants. The variables are a thing on the left-hand side, on top and on bottom. So x and t are the variables. Everything else are constants. So that means k and p are constants. If we go to tip 2a, then we want to identify whether it represents growth or decay. The x is on top of the derivative on the left-hand side, so we're looking for the sign in front of the x. It's minus, so that means it represents decay. So what's happening here is the equation says the rate of change of x with respect to t, or how x changes over time, is a decreasing function. So that's the first part. And then the p-value represents a starting point, or more like kp represents a starting point, and then the minus kx represents how quickly it decreases. So the p together with the k represent the starting point of that particular function, and it decreases. Now we know from experience that when you solve things like this, you get a log function, and this will be a log function that decreases from a certain value downwards. Okay, so we basically have the first three tips done. The next thing we want to do is write down what each letter represents, and then try to come up with some sort of story. So first of all, the x. Well, the x is in the line below the differential equation. X is the mass of dye absorbed by the cloth. And based on that differential equation, the left-hand side is saying how quickly the mass of dye is being absorbed by the cloth, and the right-hand side is saying that the amount of dye being absorbed by the cloth is decreasing with respect to time. So that's a good start. We know that the mass of dye absorbed by the cloth is decreasing. We also can see there the k is equal to 1 over 50. It's a constant, so that's fine. We know t is equal to time based on that line as well. Now we need to find out what p is. And p is in the first paragraph, so we might have to read the entire paragraph. So it's a method of dyeing a piece of cloth. We immerse it, so immerse the cloth in a container, which has p grams of dye dissolved in a fixed volume of water. Okay, so that means we got water, we have a certain amount of dye dissolved in the water, and then we're putting the cloth into it, and we know that when we put the cloth into it, the dye will go into the cloth, and based on what I've said previously, the amount of dye going into the cloth will decrease over time because it's dependent on how much dye is in the water itself. Okay, so we're getting a kind of idea here. So let's read through the question and we'll see, are we on the right track? One method of dyeing a piece of cloth is to immerse it in a container. Okay, so we've got a container and we're going to put the cloth into the container. The container has p grams of dye in water. So we start off with the container with water with the dye in it. We put the cloth into it. Okay, then it says the cloth absorbs the dye. So everything I said previously is correct. And it increases the dye at a rate proportional to the mass of dye remaining. So what that means is the dye in the water will go into the cloth, and as it does it, there's less dye in the water, and less dye in the water means that less dye will be absorbed into the cloth for each consecutive second. And that's exactly what I said before, so my understanding was quite good. T is time in seconds, x is the mass of the dye absorbed. Yeah, we've already done that. Okay, so let's go to the questions. Find the time taken to dye a piece of cloth. Okay, so we're looking for T. If a mass of 5 over 8 P needs to be absorbed to reach the desired colour. Okay, 5 over 8 P needs to be absorbed. That tells me that that's related to the X value, because X is the mass of dye absorbed by the cloth. They're using the same word, absorbed. So we have a limit there. When T is equal to T, X equals 5P over 8. And that's a second condition. It's not my initial condition, it's the second condition. It's actually the question we need to solve. So there must be somewhere an initial condition here. And the initial condition, whenever there's a time variable there, is what is happening at t equals 0. Specifically, look at the derivative, what is happening with x when t equals 0. And x is the mass of dye being absorbed by the cloth when t is equal to 0. Now, it might make sense that if you put the cloth in initially, it's not absorbing anything at the moment or anything at the start. So x equals 0 when t equals 0 will be my first limit, and x equals 5p over 8 when t equals t would be my second limit, and then I can solve for t in that case. Okay, let's have a look at the second part. So there's a new paragraph after it gives us the integral, the standard integral there that you're going to have to use with the integration. It says an alternative method. Okay, an alternative method means that that formula above is no longer going to apply. We're going to have to come up with a formula ourselves unless it's given in the section. Okay, the alternative method is to keep the mass of dye present in the water constant. Okay, at p grams by continuously adding dye throughout the process. So what that means is if the amount of dye is constant in the water, the amount of dye being absorbed into the cloth is no longer going to change. It's always going to be taking in the same amount. So that will give me the rate of mass being absorbed by the cloth, so that's dx dt, is proportional, or is proportional to p. And we're looking to find the time taken for the dye. Find the time to dye the piece of cloth to desired colour using this method. This one will obviously be quicker, and it should be quicker because the amount of dye in the water is constant throughout. So the x value, which is the dye being absorbed by the cloth each second, will be a constant in all cases. Okay, so I'll ask you to go in and do it and correct it, and I'm going to go on to 2019 and go through it again. So pause the video, do your work, come back, and we'll do 2019. Okay. I tell a lie, this is 2020 part B, so 2019 will be in the next video, I guess. All right, let's look at B. So first differential equation. Well, we have 4v to the power of n plus 1. There's not a differential equation there, so we need to form one. And the first sentence says it's a deceleration of that formula there. So that means the acceleration is minus 4v to the power of n plus 1. Does it represent growth or decline? It represents decline because there's a minus sign in front of the v, and we know the acceleration can be given by dv dt or v dv dx. So the variable on top is the v in both cases, and there's a minus in front of that. It's a decline, which makes sense because it is a deceleration. The next thing, what are the variables and constants? So if it's acceleration, and in the first paragraph as well, we can see there's a time there. The variables are velocity and time, and the constants are going to be 4, and the first paragraph as well says n is equal to a constant. Okay, write down what each of these represents. V for velocity, t for time, n is a constant that we'll fill in later on, and t is a variable as well. I think I've said that. Okay, so let's see, can we explain what's happening? So dv dt is equal to minus 4v to the power of n plus 1. So what's happening there is there's obviously deceleration. The rate of change of velocity with respect to time is decreasing, and that will vary depending on the n value. So part 1, you're just going to integrate it, get an expression for v in terms of the other things. Should be fairly straightforward. Remember that in the second paragraph it says the object has an initial speed of u. So when t is equal to 0, v is equal to u. Okay, and then part 2 says when n is equal to 3, obtain an expression for the speed p when it's travelled a distance of 3 meters. Well, we're given n, so that will go into the equation. So my equation will be acceleration is minus 4v to the power of 4. And we're looking for an expression with speed and displacement or distance. So the a will become v dv dx, and you should be able to solve that. Okay, so that's the end of the video. Next one will be 2019.